Welcome back, physics fans, and here we are going on with our first examples of a review for Physics 11 forces. We are on our third day of this, I believe, and the last couple days we just introduced what forces were. We talked about different terminology at the front here. We then talked about Newton's three laws of motion and talked specifically about the third one and the second one, of course, and gave examples. There's a sheet on the back there with terminology. We'll come back to it, but you are capable of answering them all right now. Then we spent yesterday a little bit on friction, and we had a lot of examples of using a simulator on friction and forces of friction, and what kinetic friction is and what static friction is and how they relate and how they are so different. So let's start applying these to specific questions. Here we go, number 19. A cinder block is accelerating upward at 1.5 meters per second squared, and the tension in the rope is 2.82 newtons, and using the mass as m, write out Newton's second law, winning minus losing equals ma, and solve for the unknown. So before we can write that out, we draw our free body diagram, and it is already drawn there. We have the tension up and the force of gravity down on our cinder block. And that's the finished product of our free body diagram. We don't draw anything else. We don't label anything else. We write down the acceleration if we want, but we put that outside. Okay, so we write out Newton's second law. So the sum of the forces is equal to F net is equal to ma. Now I take the forces, the sum of these forces. Which one's winning? It's going up, so tension is winning. What's losing is the force of gravity, and that has to equal ma. You have to write this line down because you're saying that I'm using Newton's second law, and this is how it applies to my free body diagram. So you need those two lines. You skip it, you're losing marks. You now start filling in the stuff that you do know. This is 282.5 minus force of gravity. We don't have the mass, but we know the formula of that is mg, and that equals ma. I'm going to spend an extra line here and just move that mg over, 282.5 newtons, and that is equal to ma plus mg. So this is going to be 282.5 newtons is equal to, if you want to plug in numbers now, we can. That's going to be m, and the acceleration is 1.5, and mg is m times 9.8. So this is going to be 282.5 newtons, and that's going to be m times, and the combination of 1.5 and 9.8 is 11.3. So m is going to be equal to 282.5 newtons divided by 11.3. And that mass is going to equal, pull up Mr. Calculator, and we get 282.5 divided by 11.3, and we get a beautiful 25 kilograms. Let's try and repeat it this time. This one is slightly different in that it's going downward at 1.5. So the free body diagram will look identical, but the force of gravity is down, and that one is winning. So acceleration is downward. Newton's second law, sum of the forces equals F net. equals MA. And then we have force of gravity is winning minus the tension is equal to MA. Quite a bit different. Okay, and we still go mg minus the tension, which is 290.5, is equal to ma. We'll take the 290 over to make it positive, and we'll put the ma over there to the other side. So we end up with 290 on one side, and on the other side we'll have mg minus ma. Last time we had plus, this time we have minus. So this is 290.5 is equal to m times 9.8 minus m times 1.5. And that is going to be m times 8.3. So m is going to equal 290.5 all over 8.3. And that mass this time is 35 kilograms. Excellent. I'll stop it there and start the next one for 21. Subscribe, smash the like, all that.